Hello again, Mustangs. This is Miss Otter. This is going to be the Math Spiral Review for May 12th, Phase 3 of our distance learning. So for the first problem, super straightforward and simple. You just had to subtract, and really there was almost no borrowing until the very end. So to go quickly through, 5 minus 5 is 0, 2 minus 0 is 2, 9 minus 7 is 2, 9 minus 1 is 8. Here's where we get the problem though. The little number is on top. So if I have 1, I cannot give you 2 of something. So I'm going to borrow from this 2, make this a 1, make this 1 an 11. 11 minus 2 is 9, and 1 minus 1 is 0. You could put a 0 here or not. It's up to you. But the answer is 98,220. The next one, it asks you to complete a true statement about which pair of fractions is greater than, less than, or if they're equal to. We did not get a chance to discuss how to talk about comparing fractions. So here's what I'm going to suggest. I'm going to zoom in so I have a little bit more space. I'm going to go ahead and show you one of the ways, and it's not fail-proof, but it will work for this one. If I have two fractions such as 1/3 and 3/5, I'm going to make a big rectangle. I'm going to split it in half. The top is going to be the 1/3, so I'm going to split the top into thirds. And then the bottom half of the rectangle is going to be 3/5. So I'm going to go ahead and I'm going to split the bottom into fifths as best as I can. Okay, so now that I have this, I'm going to make my 1/3, I'm going to make that green. So on the top, I'm going to shade the 1/3, I'm going to shade in 1 into 3 pieces. The 3/5 number, I'm going to shade into pink. And so I have 1, 2, 3 shaded out of 5. When I'm looking at this, I can see, and again, this is not always a fail-proof method, but this works for this one. When I look at the amount of shading here, I see clearly that 3/5 is bigger than 1/3 by about this much in orange. So again, not fail-proof, but it does give me an estimate of which one's bigger, and in this case, 3/5 is bigger. All right, next problem. Correctly plot the values on the number line. Hopefully you were able to see this quite clearly. I am going to stay, when you're looking at tenths, you can just look at it as 1, 3, 5, 7, 9, and 10. Same thing for the numbers that we're trying to plot. You can look at them as 2, 4, 6, and 8. So when I'm going to plot these, 2/10 is going to go between 1 and 3/10. So it's going to go right here, 2/10. 4/10 is going to go between 3/10 and 5/10, so right here. 6/10 is going to go between 5/10 and 7/10. 8/10 is going to go between 7 and 9/10. There you go. That's all you had to do on that one, is just fit those numbers in where they belong on the number line, and hopefully you realized on the tens place you were just going in order. Next, use the data from the table to create a line plot. Now, some of you may have forgotten what a line plot is. A line plot is going to be putting X's above a number line. I'm going to draw a vertical number line because I have space for it. However, if you wanted to draw it horizontal, you could have drawn it the other way. It really doesn't matter. When I'm looking at my data, I see that the biggest I have is 6.5 inches and the smallest I have is 4 inches. So I'm going to actually start my line plot at 3 and I'm going to end it at 7. So I'm going to go 3, 4, 5, 6, 7. Okay, so now my next step is to go ahead. I'm going to look at the 6 inches. 6 inches is going to fit where on the number line? Well, it's going to fit right above the 6, so I'm just going to put an X next to the 6 for that 6 inches. The next one I'm looking at is going to be 5.5 inches. This was kind of the challenge here. You had to decide where 5.5 goes. 5.5 goes somewhere between 5 and 6, or exactly between 5 and 6. So 5.5 goes here, and we just put an X where that would go. For 6 inches, I'm going to make it in green again. For 6 inches, because it's a line plot, we just put another X right next to the other one to show that we have 2 6 inches so far. Next, we have 4 inches. So I'm going to go ahead and put an X right next to the 4 for 4 inches. Okay. And then I have 5.5 inches. So again, oh, I'm going to put that in pink instead. So again, we have to look at where is 5.5 going. Since we've already labeled it with this one up here, I'm just going to put another X next to where that 5.5 is. And then we have our 6.5 inches. 6.5 means we have 6 plus another half. So that's going to go somewhere between 6 and 7, or exactly between 6 and 7 right here. And of course, last but not least, our favorite is another 6 inches, which means we're just going to put another X right next to that 6.5, 3 there. That's all a line plot is just putting X's where those numbers go. All right, compare which one has more value. Now this may seem tricky at first because you may be thinking that 4 is less than 23. But just like place value, you're not just looking at that, you're pretending like there's a 0 behind this, because this number is actually 4/10, or if I were to add another 0, it'd be 40/100, whereas this number over here is 23/100. So when you look at the fractions this way, what you're actually comparing is 40/100 greater than or less than 23/100. This is not a trick question. When you're looking at this, you can see clearly that 40 is going to be bigger than 23. The trick is to know that when you're comparing decimals, you look to the tenths place value first and then the hundredths place value. So there's a 4 in the tenths place value here and only a 2 in the tenths place value here. So therefore that 40/100 or that 4/10 is going to be greater than 23/100. All right, and the last but not least for today, look at the set of triangles shown and circle all the obtuse triangles. Obtuse triangles means that they only have to have one angle greater than 90 degrees. So it should be greater than 90 degrees. So right away, I can tell that C for sure because I can see that obtuse angle right here and know that that's bigger than 90 degrees. Looking at A, I can see that straight up like this would be a 90-degree angle. So A is also greater than 90 degree. It is also an obtuse triangle. So I'm going to go ahead and circle that. For B, it's hard for me to tell unless I change my paper around. So you may have to turn your paper to C. So when I look at B like this and I try to make that bottom line straight, then what I see is that, the 90-degree angle is actually here. And so B is actually slightly bigger than 90 degrees, which means this is also an obtuse triangle. Okay, and I'm not using a protractor because like most of you, I don't have one at home. Looking at D, actually let's go ahead and turn D. When I look at D, if I were to make that straight, if I were to make that line, I would see that D is also slightly bigger than a 90-degree angle, so D is also an obtuse triangle. The only triangle it looks like that is not an obtuse triangle is going to be E. And I can tell that because it looks like all of the angles here are all acute angles and none of them bigger than 90 degrees. So E is not going to work. Okay, short and sweet. That's it for the May 12th math. Let me know if you have any questions and I'll see you later.